Yes. Okay. At first, welcome to join the global public training. And before we talk about the detail, let's have a brief introduction about myself and also about this course. My name is Emily, and here is my email. I'm the trainer of Ruijie Regional Technology Team in the Ruijie International. And I am working for the trainer over 6 years and talk about the router, switch, wireless, security, something like this. And about this course, we have nearly 3 hours, so this is a little long. Please focus on the technology, and we will discuss the technology together. And about the course, we have 2 parts. The first one is the technology. And the second one, we will explain something about the Ruijie service and support. That means if you join Ruijie or maybe use Ruijie products, what's the service and support you can get, something like this. Of course, about this course, I have one requirement for you. If you have any problem, please directly write the question on the chat window. Maybe I can see the question, or maybe in the last, I will review the question. So if you have any problem, you can directly write. Maybe someone say, after the training, I will write down, maybe you will forget. So I only have this requirement. And after this course, we will send the PowerPoint, the material, and the video for you. So about these 3 hours, please focus on me and on this topic. It's okay for you? Yes. Okay. So now before we talk about the detail, let's have a brief introduction about the network. So here I give the typical topology for you about the network. Maybe in your real network, the topology is bigger. This is a logical one. Maybe it's about the physical topology. You have many devices than here. So maybe about the network topology, we can divide it into 2 parts. The first one is a wired network, and another one is a wireless network, something like this part, and this part. And about the wired network, we usually will divide the network into different layers. For example, about the access switch, right? And about this switch, usually directed to connect with some terminal, like the computer. And also we will use to connect with some wireless devices, like the AP, access point, right? And also maybe we will provide some power. So sometime about the access switch, we will use a PoE function to provide the power for the AP. And about this part, maybe the performance is not so well. Maybe the bandwidth is 1 gigabit is enough. But the upper layer, maybe it's a distributed layer. We usually have some high performance switch located on this layer. And about this layer, maybe the device number is less than the access switch, but the performance is better because we will connect with multiple access switch, and so many traffic will be sent out at the same time. So we need the higher performance. And of course, if maybe in your network, besides the distributed switch, we also have the core switch. Okay, about the core switch, maybe the performance is higher than the distributed layer. And later, if you want to visit the internet, we also will have a router. And maybe this router is a Ruijie Easy router, right? And provide some function like net to do the address translation, and maybe some control like ACL, and maybe we will add some policy, something like this. So within the network, sometimes we will see the enter router and the distribute switch, also maybe some core switch, and then is the access switch. This is the main structure of the network. And in this network, we also can deploy the wireless part. For example, in this topology, I add the access point, right? And we also, in some scenario, we will add the AC. AC is access controller. We maybe deploy the AC and the FAT AP together. Of course, in your network, maybe you use the FAT AP, something like this. So here is a typical topology. And why I explain the topology for you at first, because all the technology we use based on the topology. For example, between the distributed switch, maybe we will use some technology like VSU, and between different devices, we maybe will deploy the VLAN, the dynamic routing, something like this. So this is the topology. Later, I will explain some typical topology, the technology for you based on the topology. So this one, I think, is easy for you to understand, right? In the real network, maybe this icon is a router or layer 3 switch or layer 2 switch, and the cable maybe is a fiber, maybe is a twisted pairs cable, and also we have the wireless cable, something like this. So if now we deploy the device and the cable and connect with each other, and now I have a question for you. If you know the answer, or maybe you get some answer, please write down here. If we deploy the device and use cable together, what's the first parameter we have to do the configuration? Who can show me some answer? What's the first parameter we have to configure on the device if we want to communicate with each other? Yes, IP address, some answer. Management IP address, all right? And any else? Gateway IP. Yes, IP address. Yeah, I think everyone has the technology. Yeah, so one IP. Maybe the IP for the each router, maybe the IP for the devices, whatever. The first step is IP address, right? And the IP address is similar, like it's very important, right? For example, now I have a phone. If I use this one as a gift to someone, you have to tell me what's your family address, right? And in the network, the family address is like the IP address. So the first one we have to know how to give the IP address for the device, right? So let's continue. Maybe the first part we will talk about the DHCP. So what is DHCP? What's the function? And how to configure the DHCP? And what's the principle in the DHCP? So after this part, I hope you can know this. Maybe we focus on the simplest topology. Only the terminal is a computer directed to connect with one access switch, right? And then to connect with distributed switch, and then connect with the edge router, finally to with the internet. This is the simplest topology. Only one path. So about this topology, the first one, which device need IP address? Because in the chat window, I see some answer of the one interface we need IP address, right? And I also see the answer about the management IP address. This means for the network device. So which devices need IP address? I also show you some answer. We can divide the IP address to become two types. The first one is network interconnection equipment. For example, in this topology, about the edge router. Maybe about the distributed switch, this is a layer 3 switch, right? Between them to connect with each other, we have to give the IP address. And the next type is the end user. Maybe is a computer. Also in the big topology, we deploy the wireless part, right? And we have some wireless user. All of them need the IP address, and then we can work with each other. So now we know which type and which interface we need to give the IP address. And the second question is, how to give IP address for the client? Who can give me some answer? How to give IP address? DHCP. Yes, correct. Static, right? Yeah, from DHCP server. Yeah, I think you know, everyone knows the answer, right? And how to configure the IP address? One, we can use a static assignment. That means every engineer or manager to give the computer IP address. Yeah, DHCP or EG or D switch. Yes, it's correct answer. Static way, you can directly use a command or maybe use some picture to give the IP address. And the second one is the DHCP. We can use a dynamic way to assign IP address for the client. Typical scenario, of course, maybe on the EG, you also can see the other way to get IP address like PPPoE, right? And here we will talk about the DHCP. And about the DHCP, this is a dynamic host way to assign IP address. And the DHCP packets will be encapsulated into the UDP. Pay attention about this one. Actually, in the network, we have so many protocols like DHCP, like OSPF, like VLAN, something like this. And about the DHCP, how to work, how to assign IP address for the client. That means about the client, I will ask, who can help me to give me the IP address? And if the DHCP server on the network, the server will give a reply, I have IP address and please use this one. So between the client and the server, we will exchange some packets. Then I will let you know what's the IP address you can get. So this packet we call is DHCP packets because this packet is special used to assign IP address. If we use some packets to get some routing information, maybe we call this name is OSPF. So all the protocol, similar principle. And pay attention, DHCP packets. If these packets can be forwarded in the network, they have to do the encapsulation. In different layer, we will add the information. The special one is DHCP packets are encapsulated into the UDP. So what is UDP? Someone maybe also know TCP, right? So what's the difference? What's the function? If you want to know the detail about this part, maybe you can follow the YouTube channel. I will update the video to explain the detail. But about this training, you only know DHCP packets are encapsulated, the UDP is enough. And about the UDP, we will use the port number to indicate different service. And about the server, DHCP server is listening on port number 67. And the client is listening on port 68. Yes. Why we have to focus on this port number? That's because maybe in your network, you deploy the firewall, or maybe you add some ACL policy. So you have to let this port number pass through. Otherwise, I ask someone here can help me to get this IP address for me, but this packet may be filtered by your policy or maybe by your firewall. So you have to focus on this port number. So this is the first one we have to know is the port number information. And the second one, in the DHCP system, we have three typical concepts. And what's the function and who will become this concept? Let's talk about the first one is DHCP client. DHCP client means the host that needs to be get an IP address dynamically. Maybe it's a computer, maybe it's your phone, maybe it's your laptop. For this is the first one. I want to get an IP address. So this one we can call is a client. And who can help me to assign the IP address? This is a DHCP server. And who will become the DHCP server? Maybe a DHCP capable server or network device like layer 3 switch or maybe router. who can assign the IP address to client and manage the IP address. These devices we call is DHCP server. And in the network, DHCP client and the DHCP server must exist. Of course, which scenario we need the DHCP relay? Like this topology. DHCP client and the DHCP server are not in the same subnet. This subnet maybe is the same VLAN or maybe same IP segment, something like this. If they are not in the same subnet, we need to deploy the DHCP relay. And typically, generally, we will use a router or layer 3 switch to indicate the DHCP relay. So what's the function of the relay? Let's see this process. And about the client, how to get the IP address? The client will send out the broadcast packets, DHCP broadcast. This one we call is DHCP request. Hello, anyone here, and I need an IP address. Some function like this. This is a broadcast packet. If the client and the server within in the same segment, the server can directly receive the broadcast. But if not, that means the client broadcast packet sent out, the server cannot receive. So in this scenario, we need the relay. Relay will do the translation, get the broadcast packets, and then do the translation to become a DHCP unicast. And this packet finally will be sent out to DHCP server. Then the DHCP server will give a reply. Of course, this reply also is a unicast. I am here. I have the ability to assign IP address for you. This is a function. Then about the reply, I get this unicast packet. I will do the translation again to make the unicast to become broadcast packets and send to the client. So in this scenario, about the client, I will think this is a packet from the server. I don't know this packet from the relay. So this is a function of the relay. Of course, in your network, your layer 3 switch or router, we don't enable the relay function by default. If you want to do this function, you have to add some commands. So there are 3 typical concepts of the DHCP. And now we know the function of the client, relay, and server, right? So how to let the network device have this function, have this ability? We have to add some configuration. Pay attention. By default, all the devices cannot work for the DHCP. You have to add the command. And different command will have different meaning. About the client, it's very easy. You only to enable the function of DHCP, it's enough. For example, here is a picture of Windows 11. We only to select the IP assignment to become DHCP, and then after you save the configuration, the computer will send out the broadcast of DHCP packets automatically. You don't need to do anything. You only have to enable this function, it's enough. And about the DHCP server, the typical command is like this. First, we have to enable this function, service DHCP. Of course, different device, different boundary, the command may be a little different. But if you know the principle, I think it's very easy for you just to check the command, it's enough. So first step, we have to enable the DHCP server. And the command on the Ruijie switch is service DHCP. And then we have to create the DHCP pool, IP DHCP pool. Oh, here we lost the name. Every pool we have to a name. And then the next command is network 172.16.1.0, and the mask is 250.250.250.0. This command means if someone ask me to assign IP address for you, I will get IP address from this segment. So this is the command of network. And about the client, if the client want to visit the internet, one parameter is IP address, right? And the second parameter is a gateway. And here I want to ask a question for you. About the client, about the computer, what's the function of the gateway? If we don't have the gateway, can we follow the traffic successfully or not? Who can give me the answer? What's the function of the gateway? No. Yes. No is the correct answer. Oh, cool. To communicate between different networks. And this is a very correct answer. If you want to follow the traffic between different segments, we have to ask our gateway to help. So when we assign IP address for client, we also have to tell her what's your gateway address. So how to give the gateway? The command is default router 172.16.1.254. Of course, pay attention. In your network, you must have an IP address in the network device, like layer 3 switch or maybe router, to have an IP address for this one. Otherwise, the client also cannot work. Then is a DNS server, right? And you can give multiple DNS server like this 2 typical IP address. And the DNS server function is translate the domain name to become IP address, right? Because all the packets fall out, we have to do the encapsulation successfully. Add each layer parameters. About the network layer, we have to add the source IP address and destination IP address. But in the typical scenario, when we want to open a website, we only remember the domain name, like the google.com. We don't know what's the IP address. So DNS will help us to translate the google.com to become an IP address. And the next one is the list time. 0, the first is the day, second is the hour, and the third one is the minute. So this command means after 8 hours, you have to ask the server to get an IP address again. Or maybe you ask the server, I hope to continue use this IP address. So this is a function. Of course, you can give different parameter in your real network. So here is the typical command on the DHCP server. After we finish the configuration, let's check the result. The first one, we can check what's the ports you create on the network. The command is show IP DHCP port, and we can see what's the conflicted address. The command is show IP DHCP conflict. And also you can check what's the IP address already used in your network. The command is show IP DHCP bounding. And here is a typical example. Show IP DHCP bounding, and here we can see totally 3 clients in our network. And what's the MAC address? We call it hardware address. And what's the list time? What's the type? Automatic or manually or something like this. So this is a command. And some scenario, we will find the conflict address. That means different terminal, maybe we will use the same address. So what's the scenario? Maybe in your network, one terminal uses a static IP address, and then the DHCP server don't know this information, and I will assign IP address for another computer, and this IP address may be saved. So this one we call is conflict IP address. And of course, in the network, if different terminal use the same IP address, they cannot work. So this is a command we can use on the server. And about the client, some typical command we will use. The first one, we can check what's the IP address we get from the DHCP server, right? On the Windows, maybe we use the command is ipconfig all. Then we can see this command information, what's the IP address, subnet mask, and what's the gateway. And if maybe pay attention about this part, release IP address through the DHCP. That means I don't want to use this IP address. You can manually to release the IP address. The command is ipconfig release. Pay attention, record. Okay. Okay, I'm a host again. Okay, let's continue about our topic. Pay attention about this command. If you use on your computer, maybe before you get a new IP address, you will without the network. That means you cannot visit any destination because now you don't have the IP address. So if you want to use this command on your practice guide, please pay attention. This part. And of course, you can use the command renew to get a new IP address here. This IP address is a little different with the first one. So there are typical command on the client. Maybe sometime we only need the first command to check the result of the DHCP server. Okay, this is the first one. The principle is very easy, right? And the command also is very easy for you, I think. And the next one is a security risk on the DHCP. The first one is maybe in the scenario, we hope we can directly use the DHCP on the network, but still some user will use a static IP address. So the result is the IP address may be conflict. That means the static IP address and the dynamic IP address is same. So this is the first risk in our network. How to solve this problem? And the second one, maybe in our network, some user set up an illegal DHCP server. Illegal DHCP server means some server also will assign IP address for you, but you already get the IP address but cannot visit the internet. That's because in our network, we have the illegal DHCP server. So how to solve these two problems? The first one, we can use the IP source guard to solve the static IP address access. What's mean? Let's say in this topology, maybe PC1 and PC2. PC2 use a manual way to configure IP address is 10.100.1/24. And about the PC1 use the DHCP, we also get the same IP address. So if we enable this function on the server, on the access switch, the command is IP DHCP snooping, and then into the interface, we can use the command IP verify source port security, both two interfaces. These interfaces are used to connect with the terminal. And after we add this command, what's the principle of the switch? How to deal with the DHCP server? We have several steps. The first one, we will spy on the process of DHCP manage exchange. What's mean? About the switch by default. I receive the broadcast of the DHCP, I will flag. I receive the unicast of DHCP packets, I will directly forward. But after we enable this function on the switch, I will recognize to see the detailed information of the DHCP message. What's the information? About the second step, extract the relevant IP and MAC address information of the DHCP ACK message. This is acknowledgement. This is a step. First, I broadcast the request. Who can help me to give IP address? Then the server will give a reply. This is a unicast. After I get the IP address, finally I will give the acknowledgement to tell the server. Finally, I hope I can use this management. So if we enable this function on the switch will check the information of the ACK. And about this ACK message, we have the information of IP address and MAC address, right? So the switch will bound the MAC address information to the hardware table. Finally, what's the result of the switch? The MAC address will be allowed to be forwarded by the switch. Instead of setting the IP address by DHCP, such packets will be discarded by the switch. That's because finally PC1 will send the ACK to the switch, and the switch will add the MAC address into the MAC address table. But about the PC2, we only give the IP address manually, right? That means I will never send the ACK packets to the switch. So when I receive the packets from the interface 2, from PC2, I will directly discard this packet. So this is a function of the IP source guard. Of course, pay attention, maybe you give the correct manual IP address. This also has the influence. So pay attention about this scenario. This is the first one. The second one, if in our network we have the illegal DHCP server. So now we will see the video, what's the function of the illegal DHCP server. Now in this topology, we have the DHCP server correctly. And we also use a computer to deploy the illegal DHCP server. The first time, PC will send out the discovery packets. In our network, there are any DHCP server or not? Then this is a broadcast packet. So when the access switch receives this packet, I will do the flood. Flood means I will send the packets to illegal server, right? I also will copy it and then send to the call switch, and finally call switch will send to the DHCP server. Then the server will give a reply. About the illegal DHCP server, I will give you a reply. This is an offer. That means I will tell you I have the DHCP pool. I can help you to assign IP address. Then this packet will send to the PC. Of course, in this scenario, the DHCP server also will give the reply about the offer. Then about the PC, which packet is better? Who can give me the answer? Which packet is better for the PC? The first one or the second one? The legal one? Legal one? Why? Why is the legal one? Actually, about the PC, because we know the legal one is better, right? Because the legal DHCP server will give you the correct information. But about the PC don't know what means illegal or what means legal. Someone can give me the IP address, I will receive it and to get the internet. So the PC don't know. So how to choose which one is better? Who can give me the offer packets faster? I will choose which one. So the result, PC will choose the illegal DHCP offer, and then I will use this information to follow the destination, to get the internet. I will use this offer, and then I will give you the request. Okay, I know now you are DHCP server. Please give me an IP address. Then the switch will send out the packets to the illegal one, and then the illegal one will give the ACK packets, right? Give a reply, please use this IP address, something like this. So in this scenario, about the PC, finally we'll use the packets from the illegal DHCP server. But PC cannot reach the internet, right? Because about the illegal one, I will give you the wrong information. So how to solve this problem? Someone say, let PC know what is legal, what is illegal. But it is very difficult because we have the same process about the PC. I only choose a fast one. So how to solve this problem? If the access switch can recognize what means legal, what means illegal, and then if the switch don't forward the illegal packets to PC, finally PC don't know the illegal DHCP server in the network. So this is the process how to solve the illegal DHCP server. And how to let the access switch know what means illegal, what means legal. First step, we also have to enable the IP DHCP snooping. Then we can set which interface is a trust interface. The command is enter the interface and then to enable IP DHCP snooping trust. Yes, this is a key command. And after we add this command, when the switch receives a packet, I only will forward the packets from the trust interface. That means about the illegal interface also send some packets like the offer, like the ACK, the access switch will not forward to PC. So this is a command function. It's very easy as the command, right? And note, pay attention, other interfaces are untrusted interface by default. So by default, if you don't add this interface to become trust, this interface also will become untrust. So this is the typical scenario we have to know. This is a DHCP. The command is very easy to understand, right? So this is a part of the DHCP.